I will just try to make the intro up to the point that we want to consider. So I'm going to begin with the issue of looking for the case studies, because these are the ones that would be interested to look at. There's an issue here, the program, it's not, yeah. So you see this case studies or templates. I'm going to click on it. It will give me a big list of case studies, as you can see here. And what I'm going to consider is these are all solar water heating, apartment building, capital cost, hotel, motel. This is the one I meant. We are going to consider this case study, which is about, it's basically, they call it a feasibility study. So I'm going to load this. This is a case which has been run into the program. And it's the one that I'm going to open. It's loading the case study. The first thing I'm going to do is through the file, I'll go through the settings. And in the settings, I need to change the currency, because the currency here is given in terms of Indian rupees. So I'm going to change it to Saudi Arabia. So things are going to be in Saudi riyals then. If you want to keep it in dollar, it's fine. It's all up to you. But this is just the way I think it would be better. Then I'm going to go to the location. And for the location, I'm going to get in here. You see this this icon here for the map. I will click on it, and then I'm going to go here for the search. And in the search, I'm going to look for the city that I'm interested in. Dhahran, for example. It will give me the map of Dhahran. And from here, actually it has Dhahran, Safwa, Bahrain Airport, Al Jubail, Al Hufuf, Al Ruwais, and so many of the cities in the country here. I'm going to select this, and to confirm my selection, I'm going to click onto this check here, the green one, so that I would make sure that Dhahran is my current city. You can do that for whatever city that you are going to deal with. The facility that we have basically is a hotel or a motel, yes. Solar water heating, this is exactly what we need to do. That's correct. And I'll just here jump to the next one, which is about the energy. What we are considering basically is solar water heating. Originally, it was being heated by electricity. Forget about the load. This is something that we're going to come up to a little bit later, but here I'm clicking, it's the heating system, and we are using electricity. And the fuel rate for the electricity, as I mentioned, is going to be 0.3 kilowatt hour. There should be a place. I'm just trying to remind myself again about the issue of where do we change these or so. So I'm checking on that. We'll be needing hot water, and this is where we put some of the information that we are interested in. So we have a hotel or so, but our range of amount of water is 12,500 liters per day. We can do that instead of specifying the number of rooms and the occupancy rate. That's why in the morning, I just mentioned that this information might or might not be needed based on the information or what do you have in the problem. In our case, this value is specified already, 12,500 liters per day. So we don't have to worry about that a lot. It has picked up the values for Dhahran, which is basically the minimum water temperature and maximum water temperature. And then the operating hours assumed to be 24 hours per day. Then from here, that would basically be I'll come again to the initial cost a little bit later. But here they are, that's the same information that we have has been given here. The slope, Dahran has 26 slopes, so I would do it here like this. And then after that, this is the database of collectors that we have. It has selected a Tata BP Solar India glazed flat plate collector. I can click on this database button, and out of this, I can make a selection out of so many that are there. For example, I'm going to the one that I'm more familiar with which example, Califi, which is this one, which is solar flat plate, NAS 10406. This could be one of them, or you can select among others as well. So you have like a big option of database that you can make your selection of the solar collectors depending on your preference. So I'm picking any one of them here at random, and then the right check right. Here are some values that you would like to see, like the surface area, the FR tau alpha value 0.06, and the FRUL coefficient, which is the slope for 0.9, which 4.9, which means that you do not have to go for the specifications of the solar collectors because they are all stored in here. So I'm going to select that as my solar collector. And here is the recommendation that it did. It suggested that we use 28 collectors. What if I use the 28 collectors? I can take the number or I can change it from here. Actually, it will take an area of about 104 meters square. It will take care of at 68.2 kilowatts. We assume miscellaneous losses of 2%. Do we have a tank? Yes. And we are going to take the standard capacity for storage, which is 75 liters for every meter square of the solar collector. And it has told me that I need something like a storage capacity of 7.3 cubic meters, which means that when you are buying or when you are getting your solar collector system, you have to make sure that you are getting a storage tank for hot water of that size. Do we have a heat exchanger? No, we do not. The pumping power, how much is the watt per, we can just put, they do not have some sort of a specific value for it here, but so it depends, for example, how much is the power of the pump. If I say, for example, yeah, that will be too much, like 250. And then the price for the water, there should be a change where a place where we can change that price. That's actually what I'm not remembering well, but you'll find it in the video that you, if you are going to see it. This is the price of the collectors. And basically, this is what we get at the end. You know, the solar fraction, the value of the capital F that we have been calculating today as some sort of a lengthy procedure. We have to go month by month and so on and get the summations. At the end, this is what we find, that it's about 49%. This is for number of collectors of 28. What if I need to raise this to 75%? Maybe I need to change this from 28 to 50 collectors. Oh, we're close. That will make it about, yeah, maybe something like 54 is going to be, or 53. You see, it's very easy to do the changes here. And yeah, we're going to go something like 53 collectors. It will give me a 75.2. What does this mean? It means that 75% of the heating needs are going to be given by the solar collectors, and 25% are going to be by electricity. Can we do it for 100% solar, so that we have solar collectors, we have storage that's going to store the hot water so that it becomes available? Yes, but you are going to need more and more collectors then. So this can take us to something like, you see, more still needed. More still needed. It becomes a little bit picky. You see, you are increasing the number of collectors, yet the rate of increase here is not significant. And that's why, I mean, it would not probably be very much recommended that you go 100% solar for this case. But you see, you have gone from 28 or 50% up to 150, and still it's only like 97.2%. I would agree with you that you don't need it 24 hours. You don't have an occupation capacity of 100% for the hotel. You don't operate it 7 days per because normally it's not every day. Not every room has people who are using hot water, but to adjust to be on the safe side. So that's why I think values like this. Oh, sorry, that should have been. I wanted it to be 50 only. So. I mean, going something like 70% is just more than enough. Normally, you would accept a value of the solar fraction at the order of maybe between 0.5 to 0.7, like 50 to 70% is going to be good enough. And the kind of benefits that we can get from here are a lot. I would probably go back again here to the issue of energy that we were in actually for talk about the facility. We've seen the facility for the energy analysis before the comparison. There used to be somewhere, I'm sure, that we could put the energy prices, and I think it is yes, I hope that this is the one here, so that the price here is 0.3. So changing the price here is electricity and fuels. We are not using natural gas, but we are using electricity, and the rate as given in the project heading as 0.3 reals per kilowatt hour, like 30 halala per kilowatt hour. Then going back again to the solar water, you see here, I'm navigating through back and forth in the program, and what I have used so far is specifying the location, talking about the facility, and going through the energy, and then I'm going step by step, as you can see it here. If I turn to the cost, here there are some sort of some costs, for example, like the annual cost of maintenance, operation and maintenance, for example, you can put it here. This is the quantity that you are going to save later. The way that you are going to buy the unit, and then something that you can see automatically the kind of emissions that without the solar collectors you are basically using fuel, using electricity, which means that there's a power plant somewhere. You are generating 144.8 tons of CO2 per year. After using the solar collector, this number has dropped into 101. So you are saving 100, we are saving actually 43 tons of kilowatt, of tons of CO2 or carbon dioxide. You can put it in terms of barrels of oil not consumed, which means that you have saved something like 100 barrels of oil by just going from this partial use or total use of the electricity to partial use and complementing with solar energy to 70%. So we're talking about a great reduction in terms of the carbon greenhouse gases emissions by about 30%. When it comes to the finances, whatever you need to find here basically is the issue of the payback period, which means that the period of time up to the moment you have covered your saving, you have paid some sort of an initial cost, which is the price of the collectors and the price of installation, the price of the storage tank, and then you have saved a certain amount of electricity per year. This saving over several number of years, it's going to cover your initial cost. And this is basically what we have considered here. An inflation rate of 2.5, and the project operates for about 20 years. There was another place I would remember that we would get into for the price of the solar collector. That's something I just need to verify again. So it's not the fuel cost. we're talking about collector's price. Again, that's something that definitely you're going to see in the video, which is showing this. I've been actually being heavily utilizing the previous version, not this one. It seems to me like because I'm used to it, some sort of more friendly to be used. But anyway, we are talking about the solar collectors. I just want to put a location where the solar collector would be there, the solar collector price, and this is what I'm trying to check. But definitely, if we are able to look at the video, it will take you there anyway. So basically, this is all that you have to do. It's a selection of the city that you are in, or that you are going to have your project running at, and going through the process: location, city, and then this is basically you're going to begin with applying or uploading the case study, going to specify the city that you are in from this button, then going for facility. You are not going to change much here, but basically we're talking about a hotel and motel, solar water heating, and basically it's Eastern Saudi Arabia, Dhahran. And then talking about energy, this is basically where you are going to go through these units here one by one. Electricity and fuels, the price for the electricity is going to be placed here. We said that we're going to operate like 24 hours. Here you can specify, for example, certain hours on Monday, less hours on Tuesday, more hours on Sundays. And for hotels, normally they do something like this. They just say that over the weekends, we expect maybe 80% occupancy, but for the rest of the week, we're getting like 60%. Or the number of hours where the collectors are going to be utilized. I mean, how much heating you need per day. So you can specify that here. Then we're talking about heating. So the heating system, basically, originally it was the base case of electricity. In the proposed case, you are still going to use electricity, but with solar collectors. And you can change here from electricity to anything else. You can use electricity or natural gas as the source of energy that you would like to have. The hot water, basically this is where we put the rest of the kind of information that we have for the system. That the kind of liters per day, which is given in the example or the project. 60 is the temperature to which we need to heat the water. These are automatically there, the 22.5 and 24, operating hours, 24 hours per day assumed. And then we're going to get into the solar water heating details. The solar heater is going to be placed on a slope of 26. And here you can change this. Whenever you go to the software, the values of the FR tau alpha coefficient and the FRUL are going to be utilized or going to be obtained directly from the database. It is going to propose a certain number of collectors. You can take it or you can change it, as you can see here. And then at the end, you are going to use this as 75, which is the standard storage. Price of electricity has been taken from the previous slide. And then finally, we're talking about, is this where we can change the values? Oh, yes. So we're talking about, this is some sort of a hand calculations part based, because the prices of the collectors keep changing. We're talking about using 50 collectors. If we assume that each collector is going to cost like 4,000 reals, so we're talking about a total cost 100,000 reals that should be there at the beginning to buy the collector. And after that, when you go to the issue of the finance, it will give you a payback period of less than 9 years. You can have something here like incentives. For example, you can see that the government is going to provide us with an incentive. And the incentive is, let's assume the government is going to pay, for example, 50% of the price, like making a 50% reduction in the price. So that's something that can be done, and you can say, or maybe a fixed value. 100,000 is going to be a share of of the country in, and then you can see the payback period drops a lot. And this is something that we have made a recommendation maybe a few years ago, that we would like to have incentives given to encourage people to go for the solar collectors. Like when you are buying water here, the water is being utilizing energy, and this energy has been subsidized. So the price is not the real price, but it's less than that. And something like that can be seen here. So in this page, you can put if there are incentives. You don't have to do that for our case for the project anyway. But I'm just telling you that that's something that can also be used here. Is it clear?
Yes, Doctor.
Fine. I hope it's straightforward. What you need to do for the project is that on the page of the energy, where you are going to reach to the point where the calculations are being done here, when I'm talking about the changing the number of collectors, then basically you're going to change the number here, and accordingly you are going to see what's the solar fraction here. Then you can even try to make a plot. If we have 28 as what's recommended, the solar fraction is about 50%. But if we made them 35, the solar fraction becomes 58%. If they are 40, then the solar fraction is 64%. You can write this down, put it in Excel, and then you can plot what the number of collector versus the solar fraction, for example. So that's something that can be done. You can make a comparison between this and an evacuated tube type of collector. And for the evacuated tube collector, you can go to the database and get whatever the brand, but you can go for another type of evacuated tube collector. I think there's something here that I should, it's not a glazed type, but we're looking for a different type here, which is, as I mentioned, we're looking for evacuated tube collector, and there is unglazed. The unglazed basically is the one which is used for swimming pools that does not have a cover. Other here, this is if you have a new collector and its data are not there in the database, it will give you an opportunity to enter these values of the efficiency parameters in and the surface area. So if it's not stored in, then these are values you have to put yourself. Otherwise, if you decided to use whatever is being there in the database, then you simply make your selection out of this.
Doctor.
Yes.
When you said that unglazed, that's using like in swimming pool, what do you mean by that?
I mean that in swimming pools, if you go back to chapter 6 presentations, you'll find that there are some cases where you use solar collectors that are not covered with glass. Convection losses are high. Accordingly, you cannot heat the water to high temperature. But in a swimming pool, you don't need high temperature. So it probably would go for buying what we can say a cheap collector that's going to heat the water only up to maybe 30 to 32 degrees centigrade. So you are making a cut in the cost of the solar collector, knowing the efficiency is not high, but it's fine. It's okay because the temperature needed is not high.
Okay. Thank you.
Okay. Fine. Okay, Shabab. So that's it for this short demo. So don't forget, number one, to upload the case study. Number two, to change the city to your city. And after that, you're going to go like step by step and put your information in there. Further questions?
Thank you so much, Doctor.
Okay, Abdurrahman, afwan. فأمان الله.
Aman. Doctor.
تفضل.
Actually, I have a question in private. So.